following two problems in the tutorials Engineering Mechanics are dealing with friction. Friction is a very important topic also in the industry, but in our course we want to focus only on one friction model, which is the so-called Coulomb friction model. The Coulomb friction model is a model which works well for so-called dry friction, so that you have no lubrication, and the Coulomb friction law can be stated quite easily and can be determined quite easily, and that is the reason why it is so popular. For Coulomb's friction model, I just have a very simple example. I think Alex uses a similar example in the lecture. It's just a block which stands on the ground, and there is a force F applied, attractive force, which tries to pull the block to the right. You can see the block has the mass of m, and there is the acceleration of gravity g acting downwards. So due to the acceleration of gravity, there is of course a weight force acting downwards as well. So what would happen if we would have no friction at all? Applying this force F, of course our block would start to slide. But all of you know that in reality, even if you apply a small force, there might be the case that the block remains in rest, so you have to increase the force until it starts to slide. And that is due to friction, so there is a force which prevents this moving to the left or to the right. And we can divide two different cases in statics for friction. First of all, we have static friction, and secondly, we have kinetic friction, or so-called sliding friction. The difference between those two cases can be evaluated by looking at the two contact partners. So in this case, our contact partner 1 is the environment, and the contact partner 2 is this block. The environment is in rest, and that means if the block is in rest itself, then both contact partners are in rest. That means there is no relative velocity between the two contact partners, and therefore we would have the case of static friction. But if we have some sliding of the block, then we speak of kinetic friction, and this is due to the fact that we have a so-called relative velocity. To calculate the friction forces out of Coulomb's friction law, we first of all have to make a free body diagram and state the equilibrium conditions for our block. Rather simple, the first two parts. We just plug in this external force which is acting. We plug in the weight force, m times g, which is acting in the centroid of the block. And then we have to add two additional forces in the contact. Those two forces are marked here in y direction, so in vertical direction, this normal force Fn, and in horizontal direction, this force Fr. What are the two forces? The normal force is a force which is applied from the environment to the block. If we would have no normal force, then the block just would fall into the ground, and this normal force now prevents the penetration between the two contact partners. In this case, you can easily see that the normal force has the same amount as the weight force, it just balances the weight. And the friction force, Fr, is also entered here in the free body diagram because we want to fulfill the equilibrium of forces in horizontal direction as well. And as there is a force applied on the right side of the block, then of course there is also an additional force acting to the other direction necessary to balance the force F so that the equilibrium conditions are fulfilled. As already mentioned, we can determine we can divide between two different cases. First case, static friction, no relative velocity. Still there is a friction force which prevents that the body starts to slide to the right. And second case, the kinetic friction. If we have a sliding to the right and the sliding is with constant velocity, then still there is no acceleration in our system, so the equilibrium conditions would be fulfilled. That means if F equals Fr, then our body could also slide with constant velocity to the right. Still, the equilibrium conditions and therefore the static conditions would be fulfilled. Now, Coulomb's friction law tries to find a link between the normal force and the friction force in this frictional contact, and there we also have to divide between the two cases, static friction and kinetic friction. In case of static friction, our friction force, Fr, is a so-called reaction force. That means you cannot determine the amount of Fr in advance out of the normal force, but you have to determine the amount of Fr out of your equilibrium conditions, so out of the free body diagram. And then you can check only with this inequality condition, which is given for static friction by Coulomb's law, you can check whether the friction force is within some boundaries which are defined by mu naught times Fn, where Fn is the normal force and mu naught is the so-called coefficient of static friction. The absolute amount signs in this Fr are due to the fact that we do not know in advance the amount of the friction force, and we do not know in advance the direction of the friction force. So it could act to the left or to the right, as it is a reaction force. And you know, out of the calculation when you had bearing reactions, you can choose an arbitrary direction for the friction force in case of static friction. And by setting up the equations, the equilibrium conditions, if you have a negative sign, then your assumption that it would act in such a direction as in the free body diagram was wrong. In reality, it would act in the opposite direction. Yeah, and in case of kinetic friction, the thing is much simpler. The friction force in case of kinetic friction can be directly calculated out of the normal force. It is just to be multiplied with mu, which is the coefficient of kinetic friction or coefficient of sliding friction. Both coefficients, the coefficient of static friction mu naught and the coefficient of kinetic friction mu, depend on the material pairing. So what is the material of the underground and what is the material of the block in this case? And of course, this could also be influenced by the harshness of the material. You can look the coefficients of static friction and sliding frictions up in the formulary or in some textbooks. And what is important to know is that in most cases, the coefficient of static friction is bigger than the coefficient of sliding friction. So that means if your system is in rest and you try to start the movement, you have to apply a quite big force. But if it is already moving, and just to keep the velocity constant, the necessary force can be lower than the force which is necessary to start the motion.